Hello, in this video, let's talk about the logarithmic functions. So, for example, let's suppose we wanted to solve something like 3 to the x equals to 15. We know that 3 squared is 9. We also know that 3 cubed is 27. So our answer is somewhere between 2 and 3. So it's some decimal 2 point something that is the actual answer. But what is it? What is the actual power that we have to raise 3 to get 15? That's where the logarithms come in. So logarithmic functions allow us to undo the exponents. So the way this works is we have logarithm, and then the base number is 3. So the base always stays on the bottom. And because the logarithms are the inverse of the exponential, the input and the output switch place. So right now we have 3 with the x. With the logs, 3 is going to get 15, and the x is going to be on the other side of the equal sign. So this would be log base 3 of 15 is equal to x. Now, on one hand, wonderful, we have x. We solved it. But what is it? What is the number that actually works? We don't know yet. Now, on a calculator, we have 2 buttons. So here is our calculator. It has 2 buttons that deals with logarithms. The first one is, let's look at it closer. So here's the calculator. The first one is log, and the second one is ln. Log is the one with base 10. ln is the one with base e. So if we had log base 10 or log base e, we could just press the button and get the answer. But because we don't have any one of those, we have to use something else. Now, on our calculator, there is, if we go to the math and we scroll down to choice A, that would be log with a base, with any base. And if your calculator is equipped with this feature, then we can just type in the answer, because we get 2 empty spaces, log base 3 of 15, and the answer is 2.4649, just like we thought it would be something between 2 and 3, and that's exactly what it is. It's 2.46 something. So that answer, x, is about 2.4649. And when we deal with exponents, it's a good idea to keep more decimal places. Usually 3 decimal places is good. For exponents, perhaps 4 or 5 decimals may even be better. So to check, let's see if it actually works. So if we take 3 to the power 2.46497352, the answer is 15. Now, if we just round it a little bit, 3 to the power 2.46, the answer is no longer 15, it's something close to 15, but it's not 15. That's why it's important to keep more decimal places when we deal with exponents and logs. So that's what logarithms are. So logarithmic functions, they undo. They are the inverses of the exponents, and they cancel exponents, just like we did. We figured out what the exponent was using the logarithms. So here is the basic structure. The exponential will have something to the power equals a number, such as 3 squared is 9. Logarithmic will have it switched, so the base will be on the bottom, but the d and the a, the input and output, would switch. So it would look like logarithm base 3 of 9 is 2. Now, all of the logarithms when we make a sketch of them, they all have a very particular look to them. They all look something like this. And that's important because we notice that this curve will never cross over the y-axis. So log of any base, no matter what base it is, can never have on the inside anything that is negative or anything that is equal to 0, because equal to 0 means it will hit its vertical asymptote, and negative will mean it crosses over. And we know that we cannot cross the vertical asymptote, we can only approach it. So here is what the graph of most of the logarithms will look like. If we do not have the feature to use any base, then we need to use what's known as change of base formula. So for the same example, we could use change of base formula, and as the name says, it allows us to change from the base 3 to any other base we want. And the base we want is the one we have on the calculator, which is base e or base 10. So the change of base formula works like this. We take logarithm of our base and we switch it to logarithm of any base we want. So if we just use log, that's base 10. So if we have log 15 divided by log 3, that is using the change of base formula. Change of base formula says that if we have log of any base that we don't want, and we want to switch to the base we do want, let's say c, then we divide them. We divide log a by log b. And that's what change of base formula looks like. Now, with the calculator, let's see if we get the same answer. So here is our previous answer, 2.46 something. Now let's type in log of 15 divided by log of 3, log 3. And here is the answer. It's the same decimal, 2.46, exactly the same. If we used, instead we used ln, natural log, ln, we'd get exactly the same solution. As long as the base we change into is the same, it will work. So here is natural log, same answer. So just as a reminder, the two buttons that we have on our calculator are the log button, which means we have base 10, and then ln button, which is natural logarithm, which is log base e. So these two we have on our calculator. For everything else, we need to use either the change of base formula or the button with a different base. And that's it for this video. If you have any questions, please leave a comment. Thanks a lot for your time. Take care.